going back to RLHF, which has been a huge focus of yours, not only at the Allen Institute, but also at Hugging Face, where you were previously. In your paper, The Alignment Ceiling, you discuss the issue of objective mismatch in RLHF. So, what are the challenges in aligning reward models with human preferences in a reproducible manner?
Yeah, so this paper is kind of a fun story because it harkens back to my PhD. So the PhD work on model-based RL, like the objective mismatch paper, was kind of my like core paper of my thesis, which is that in model-based RL, you're learning a policy in a dynamics model. So it's a bit simpler because the evaluation regime is much more closed. So like in classic RL, you have these like robot tasks and simulation. So the evaluation is much more set. And then you can kind of think of it as like the dynamics model that is good for the policy is tuned to the policy. It's not tuned to the real world. In RLHF, it's a bit different because you're kind of trying to do like a multi-stage process where you have like this language model, which is your policy. You have this reward model, which is like sort of like your environment, but it's mirroring to what the humans want. So there's this extra leg of trying to like match what the humans want, and then you have this reward model, and then you have the policy that's trying to extract information out of it. There's a lot of analogies. I've been recently talking about like information flow, which is like if you have this policy that's getting trained, the reward model is some sort of filter or sieve or like gain. You can think of it as many different ways. And you need to tune that. There's like you're putting information through a black box, and you need to tune it to make sure that it matches what humans actually want. I think this is part of why the model spec is interesting. So doubling down on what the model spec partially reveals is that when these big companies are collecting preference data from humans, they have like 10 to 20 page documents on here's what you should prioritize when you're labeling the data. And the model, and then the question that we haven't been able to see of these models is what is the mismatch between what they tell you to do in the data and what the final model does? So if you tell them in the data, like prioritize factuality, prioritize conciseness, like even if the data has that, does the training process result in a model that does this? And that's kind of like the best representation of what we're saying is like this alignment ceiling is like, we don't know if our methods ever could actually be perfectly aligned with what our expectations are because we're doing this all in different modules. And then the really deep, this is less in vogue right now, but in deep RL days, people would be like, can't we just do end-to-end learning? So if we only have one objective, can it learn everything at once? And that just doesn't seem to scale as well in like realistic engineering environments. I think the only people that we see doing that is like Tesla self-driving. And we don't know for sure if they are, but all of the teams at OpenAI, Gemini, Anthropic, they have modules where it's like an RLHF team, a safety team, a pre-training team. And like that is where they trade off these things. And those are like, if you look at this paper, that's what each of those boundaries are, where you're trying to design your optimization in the context of the optimization that other people are doing. So it's kind of it's just this mathematical thing where it's like you can never get a perfect solution if you're doing multiple optimization problems.